Good morning, everyone. Today we're going to look at the trigonometric identities. So those two identities you need to memorize by heart, where cos squared a plus sin squared a is same as 1. So a could represent any angle. It could be cos squared theta, it could be cos squared b, it could be cos squared 30, it could be sin squared a, sin squared b, and sin squared theta. So this a could represent any angles. Also, that tan theta is the same as sin theta divided by cos theta. So let's look at how we could simplify sin squared 3 theta plus cos squared theta. So from the first one, we know that cos squared a plus sin squared a is the same as 1. Therefore, we can replace the a with 3 theta. Therefore, so 3 theta could be represented by a and a. So this is the same as 1. And the second question, we have 5 minus 5 sin squared theta. We can factorize this. So we can take 5 outside the bracket. Then we have 1 minus sin squared theta. So from our identity, we know that cos squared a plus sin squared a is the same as 1. Therefore, 1 minus, if we just rearrange this part, so 1 minus sin squared a is the same as cos squared theta. Therefore, we know that this part here would just equal to sin squared theta. So we have 5 cos squared theta. Okay, let's look at the third one. So we have sin 2 theta divided by 1 minus sin squared 2 theta. Again, using our trig identities, we have sin 2 theta divided by, so again here, 1 minus sin theta, sin squared theta is the same as cos squared theta. But in this case, instead of theta, we have 2 theta. So we have 1 minus sin squared 2 theta is the same as cos squared 2 theta. So we have square root of cos squared 2 theta. Remember, cos squared 2 theta basically just means, so let's note here, so cos squared 2 theta is the same as cos 2 theta multiplied by cos 2 theta. So we know this is the same as sin 2 theta divided by cos 2 theta if we take the square root of cos squared. And then just look back to our tan. So we know tan theta is the same as sin theta divided by cos theta. So we have here sin 2 theta divided by cos 2 theta. Therefore, our final solution is tan 2 theta. So question 4 is a proof question. So we have cos to the power of 4 theta minus sin to the power of 4 theta divided by cos squared theta. So we need to show this is the same as 1 minus tan squared theta. So firstly, this part, we can see this is the difference of two squared numbers. So we can have cos squared theta plus sin squared theta. It is cos squared theta minus sin squared theta. And on the bottom, we have cos squared theta. Then we recognize this as from our identity. Cos squared theta plus sin squared theta is the same as 1. So this part of the bracket would just equals to 1. So we're left with cos squared theta minus sin squared theta over cos squared theta. So cos squared theta over cos squared theta would just be equals to 1. Then sin squared theta divided by cos squared theta. So from our identity, sin theta over cos theta is tan theta. So this is minus tan squared theta. So again, you can also write this out as cos squared theta over cos squared theta. So just help you to easy to look at simplify minus sin squared theta over cos